Welcome to September 7th LeetCode challenge. Construct string from binary tree. Given the root of a binary tree, construct a string consisting of parentheses and integers from a binary tree with the pre-ordered traversal way and return it. Omit all the empty parentheses pairs that do not affect the one-to-one mapping relationship between string to the original binary tree. So in example number 1 here we have binary tree of 1, 2, 3, 4, and we want to create a string out of that. So we know that originally it needs to be the following, right? It needs to be 1, then these get paired together, and then we know that basically 4 is paired together with 2. However, we need to remove the empty one, so therefore we have null here, so remove that, and therefore we have basically 2 is parentheses to 4, and then we have 3 here, which is connected to null, which is also removed because it's empty, therefore we have parentheses 1 and 3. So basically the answer would be 1 parentheses, and then we have 2 parentheses 4, which is all connected together, and then we have 3 alone. So next on we have example 2, we have 1, 2, 3, null, 4. So it's almost similar to the first example, except we can't omit the first parentheses pair because it breaks a one-to-one mapping relationship between the input and the output. So basically we need to have the no parentheses here, right? And that's the important part as well. Don't want to affect the one-to-one mapping. So constraints of the number of nodes of the tree, this ranges between 1 to 10 to the 4, and the value of each node is between -1,000 to 1,000. And let's find a way so that we can solve this tree to string. So the first thing we want to do is initialize a string with a root.val. So say we call this string, and then we do we initialize it with a string of root.value or .val. So if the root is not empty, left value subtree, then we want to basically do the following: root.left. We want to traverse through the left node, through the left roots of the tree, and wrap everything it returns into parentheses. So that will be something like string, and we're going to concatenate it with the following. So we have the first one, and then we want to take self.tree to string. I'm going to call upon root.left. Concatenate that with the right side parentheses. Alright, and that should work for that one. Similarly, if the root has a non-empty right subtree, root.right, then we're going to do a similar thing where we, similar thing. If the left subtree is empty, we don't need to add an empty, we don't actually need to add a empty parentheses before the actual content of the right subtree. So we can't differentiate whether it's from the right, from the left, or of the right subtree. So we have to add an empty parentheses. So if we consider the case where we have basically a subtree that has basically this 2 and 4, then we basically remove the empty parentheses afterwards. However, if we have the situation where we have 2 and null 4, then we have to leave the empty parentheses inside because it will break the one-to-one mapping relationship. So that means that we have to find if not root.left, then we want to basically concatenate the string with an empty parentheses. Alright. And then we also want to concatenate a string with the actual value itself. So that'll be concatenate with self.tree to string, calling upon passing through root.write, concatenate that with a closing parentheses. Alright, and then we exit this loop. We need to return the string. And that would be right here. Let's run this code and check it out. Ooh. Okay, initialize string. String.root.all if self.tree to string right, if right, if not root.left. Then we want to string concatenate with that. Oh, this would actually be in that bracket. Alright, there you go. So this is running at a big O of n log n time complexity, for n is the size of the node. Each time we iterate through it, we just get a little bit less. Because it does run recursively, actually. Size memory complexity is big O of n times, because we're returning basically at most. We're returning a string, so it's big O of constant time. Constant memory. Alright, that's it. Have a great day, guys.